Hello, good morning to everyone. So today's class, we will see the 10th experiment, that is active filters. In that you will have high pass filter and low pass filter. Low pass filter, it passes the low frequency and attenuates the high frequency. High pass filter means it passes the high frequency and attenuates the low frequency. So this, in that you will have second order filter, first order filter, like that. If you are having one RC pair, you will have first order filter, two RC pair, second order filter. So this is the second order low pass filter. So for this, you should connect the circuit diagram as per the connection. Once you are given the connection, you provide the input and output. So input, you will give 1 volt, then that should be amplified based on this RC values. You will get the amplified output. So what you have to do, so increasing the different frequency, and you should take the output voltage. So various frequency. So this is the response of the low pass filter. So it's constant, then it's decreased. So what you have to do, so you should have keep on increasing the frequency 50, 100, 150, 200, 500, 1000 kilohertz, like that. So you should note down the output voltage. So throughout that, the input is constant. Then you should calculate gain is 20 log V naught by Vi. Okay. So after that, you should plot this in the semi-log graph sheet. Okay, so gain versus frequency. So here you should take the output voltage up to some frequency. The output voltage is constant, peak to peak value. After that, it starts decrease. So you should find out from which range to which range is constant. So in between 3 to 4 5 readings you should take. Okay, then you should calculate the gain. Once you are done, you plot these in the similar graph sheet. So after plotting that, so this is the maximum gain, how much you are getting. From that, you minus 3 decibel line. Suppose, for example, gain you are getting 15 decibel, minus 3 means 12 decibel. So here you draw the line. So that line cuts your graph at one particular point. That is your cutoff frequency. So in this problem, we designed the cutoff frequency is 1 kilohertz. Okay. So for 1 by 2 pi RC. So that 1 kilohertz, we are find out the R and C values. So this RF and RI determines the gain of the amplifier. So this RC pair determine the frequency. Okay. So from the similar graph sheet, you obtain the frequency. So theoretical frequency is 1 kilohertz. Practical frequency, after plotting that how much you are getting, you should write. Similarly, for high pass filter, just interchange the position of the resistor and capacitor. Then repeat the same process. Okay. Then you will get a high pass filter. So here, how you should take the reading. So you should keep on increasing the frequency up to some frequency. The output voltage is increasing. So you should find out the minimum and maximum frequency up to which range it's increasing. So within that, some 3 to 4, 5 readings you should take. After that, the output voltage is constant. So in the constant range, you should take some 4 to 5 readings. So totally around 10 readings you can take. Calculate the gain, then plot this in frequency, that is similar graph sheet. You will obtain the frequency response. Then draw the 3 decibel line, obtain the cutoff frequency. So this is the cutoff frequency. Okay. So verify the theoretical and practical frequency. Now I'll show the simulation. So you want to do the simulation. So for that, from here you can take op amp, 5 terminal op amp, then you connect it, then power supply for those two things, then RC. So as per the circuit diagram, you can connect it. Now AC source you take 1 volt, 50 hertz first I am given. So run the simulation. So you got the output. So stop it. So here 0 to some 500 milliseconds you can give. So you will get the thing. So see, my this green color one is the input voltage. So the peak to peak input is 2 volt. Okay. Then this one output voltage is 1.58 volt. Okay. Similarly, then vary the frequency 50 to some 100,000 like that. So you find out up to which frequency this will maintain the same magnitude constant value. Okay, 1.58. So here, suppose if you are taken input is peak to peak 2 volt means output is also you should take peak to peak. Instead of that, peak value alone you can take from 0 to input is 1 volt. Okay, output is 1.5828. So gain is 1.5 output divided by input, that is 1.5828 divided by 1 volt, then 20 log of that value. So that you fill the table, then in the similar graph sheet you plot it. Okay, in the similar graph sheet, so each scale will be, if first initially if you are taken that is 100,000, then 10,000 like that it will be varying. Okay, so for plotting the response, if you have any doubt, I will clarify to that. So after that, you do the high pass filter. Just interchange the position of the resistor and capacitor. So repeat the same process. Okay. So clear. So complete it and submit.